Okay, let's continue. Let's solve one question from GP itself, then we will be moving to harmonic progression. Let's solve it. So suppose our question is, suppose A, B, C are in AP and A square, B square, C square are in GP. If A is smaller than B is smaller than C and A plus B plus C is equals to 3 over 2, then the value of A is, so here let's focus on, okay, the options are also given over here. 1 by 2 root 2, B is 1 by 2 root 3, C is 1 by 2 minus 1 by root 3 and D is 1 by 2 minus 1 by root 2. Just give me a second. Yeah. So if this is the question we are having, suppose A, B, C are in AP. So let's solve it. How to proceed in this question? A, B, C are in AP and A square, B square, C square are in GP. So if A, B, C are in AP, what can be written for that? Can we write 2B is equals to A plus C since it is in AP? Can we?
Yes, ma'am.
Let's write it. A, B, C are in AP. Then we can write twice B is equals to A plus C. Equation number 1. Now the next condition says A square, B square, C square are in GP. So if A square, B square, C square are in GP, then U can be written for that. If A, B, C are in GP, then what to see? Do you know this?
Yes, ma'am.
Let's apply it over here. So B square, that means this middle terms square is equals to this. Is it clear so far? Is it clear, Lina? Let's give it a name, equation number 2. Now, what we are having in hand, the information given in the question itself, that A plus B plus C is equals to 3 by 2. So, A plus B plus C is equals to 3 by 2. It is given in the question itself, right? Right, Lina?
Yes, ma'am.
Now, let's substitute the value from equation number 1. So A and C means 2B. So we can write 2B plus B is equals to 3 by 2. We can write 3B is equals to 3 by 2. And can we say what will be the B value from here? Tell me.
1 by 2.
Now value, if we will be substituting b value in equation number 1, a plus c is equals to 2b. 2b. B value I am going to substitute as a 1 by 2. So a plus c is equals to 1 we will be getting, right Lina?
Yes, ma'am.
Now equation number 2 says that b squares whole square is equals to a square c square. From 2, if we will customize equation number 2, can we write, okay, let's substitute this b value in equation number 2 also, and let's see what exactly are we getting. So from 2, if we will substitute the b value in equation number 2, what we will be getting? This is, let's say, 3. So b square whole square is equals to a square c square. That is what the equation number 2 we are having in hand. Now if we will be substituting 1 by 2 over there, so 1 by 2 whole square, and that's again whole square is equals, so 1 by 4, if we will be removing this square and sending it to other side, it will, that means 1 by 4 is equals to plus minus AC, or is equals to, right Lena?
Yes, ma'am.
Plus minus 1 by 4, and we also have a plus c is equals to 1. So we do have a plus c is equals to 1, and we have a c is equals to plus minus 1 by 4. What exactly we want? Value of a, can you see? Then the value of a is, okay, so here if we will be solving this two equation, ac is, ac value is 1 by 4, AC value is minus 1 by 4. These are the two values we are having. Okay. 1 by 1, case 1 and case 2 we will be using for what? To calculate the value of A. Okay. So A plus C is equals to 1. So can we say from here C is equals to 1 by 4A? From case 1, let's solve case 1 at first. C is equals to 1 by 4A. And this equation, let's say it was 3. So A plus C, that means 1 by 4A is equals to 1. Is it clear?
Yes, ma'am.
4A square plus 1 is equals to, by 4A you can say for a while. So 4A square plus 1 is equals to 4A we can write, right?
Yes, ma'am.
So 4A square minus 4A plus 1 is equals to 0. What A value we will be getting from here? Can you tell me? Can we make it a perfect square? 2A square minus 2 into 2A plus 1 square. So can we say it is 2A minus 1 whole square? Can we say it, Lena?
Yes, ma'am.
So A value we will be getting as a 1 by 2, right?
Yes, ma'am.
And what will be C value? B value what we have got? B value also we have got 1 by 2. Okay. Let's see what the other case is giving. So other case, AC is 1 by 4. 4. Okay. Now the equation is A plus C is equals to 1. Here we will be using C value, that is A minus 1 by 4A is equals to 1. That means 4A square minus 1 is equals to 4A. That means 4A square, here minus 4A minus 1 is equals to 0. Now, how to factorize it? Any idea? How to factorize it, Lina? We can simply go ahead and apply the formula whenever we don't know whether perfect square method will work or not, whether factorizing with the help of the numbers will work or not. Then quadratic formula will always work. That is minus b, that is b is minus 4, plus minus under root b square. B square is 4 square minus 4ac, 4 times a times c, divided by 2a. So 4 plus minus under root 16 plus 16 divided by 8. Are you getting it? Do you know this
Yes,
formula?
ma'am. Yes, ma'am.
4 plus minus root 32 divided by 8. That means 8 4 times 32, or 32 means 2 to the power 5. So 4 will come out. So 4 plus minus 4 root 2 divided by 8. Let's take out 4 common. So we will be having 1 plus minus root 2 by 2. So two values we got from here, 1 plus root 2 by 2 and 1 minus root 2 by 2 as a value, a. Okay. Now we have already got three different a values. A value is 1 by 2. A value is 1 plus root 2 by 2. A value is 1 minus root 2 by 2. Now which option we will be marking, because it's asking for a value. So here if you will look at the condition, a must be smaller than b. And what was b? B was 1 by 2. So the first result which we have got, we have to reject it. Right, Lena? Because a is
Yes, ma'am.
smaller than b, the condition is given and it is not getting fulfilled over here. What about the other two? The other two, 1 plus root 2 by 2. Okay, 1 plus root 2 by 2. If you will look at it carefully, can I separate it with by 1 by 2 plus root 2 by 2?
Yes, ma'am.
Again, it's smaller than b. So that, right? Right, Lina?
Yes, ma'am.
This is also we will reject. What about the third one? 1 by 2 minus root 2 by 2. Maybe this option we will be getting 1 by 2 minus root 2 by 2. Okay, the last option is 1 by 2 minus 1 by root 2. So it's same, right? If we will rationalize this part, root 2 by root 2, this part, only this part will become 2 by 2 root 2, right? 2 and 2 gone. So we ended up getting 1 by 2 minus 1 by root 2, right?
Yes, ma'am.
Rightly. Let's summarize the whole thing. So suppose A, B, C are in AP and A square, B square, C square are in GP. And one more equation is given. We are writing one equation from the first case AP, the another equation from the second case GP, and the third equation is already given. Now everything we are just trying to solve and find the value of A. We ended up having few cases. We have solved all the cases, but we realized that one of the or two of the value of a is not acceptable, because a has to be smaller than b. Accordingly, we have taken a value which is smaller than b and we have marked the answer. Is it clear?
Yes, ma'am.
Let's move ahead. If the question says, let a, b, c be in gp with common ratio r, where a is not equals to 0 and R lies between 0, 1 by 2 if 3A, 7B, 15C are the first three terms of an fourth term of this AP. We will be coming to this question, but before that, since it is already related to GP only, let's discuss first thing first, that is what is harmonic progression and what is AGP, because we need to cover those also. Then we will get back to this question, no worries. Let me write the options as well. 2 by 3A, B is 5A, C is 7 by 3A, and D is A. We will be coming to this question after a while. But before that, let's understand what is harmonic progression. Applying the same number with each and every term. Here, what the definition says, a sequence in which the reciprocal of the terms form an AP is called harmonic progression. As the definition says, here the sequence must be having the reciprocal term, like whatever term is given in harmonic, you will end up having an AP. Such sequence is called harmonic progression. So if you are having 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, okay, a sequence like this, then you can take the reciprocal of each and every one. So the first term reciprocal is 1, the second term reciprocal is 2 by 1, that is only 2, the third term reciprocal is 3 by 1, that is 3, the fourth term reciprocal is 4 by 1, that is 4, fifth term reciprocal is 5 by 1, that is 5. Can you see it's in AP?
Yes, ma'am.
Previously, it was in HP. Once we have taken the reciprocal of each and every term, it became an AP. So, we will not be discussing about a general specific rule for harmonic progression and all. We will understand the concept that it generally came from the arithmetic progression only. Okay, it's the reciprocal of that arithmetic progression. So, if you are having, just a second. Let me take a basic question related to that so that you can understand. Okay, so if we are having one question which says if x is equals to summation of n is equals to 0 to infinity. Please don't worry with the summation thing. Okay, I am going to explain it. Was to summation of n is equals to 0 to infinity b to the power n, and z is equals to summation of n is equals to 0 to infinity c to the power n. Then where a, b, c are in AP and modulus of a modulus of a is less than 1, modulus of b is less than 1, and modulus of c is less than 1. X, y, z are in. So here x is equals to, just a second now. Yeah, so we can write x over here. Let's continue. We can write x, since x is given as a summation of equals to 0 to infinity. This may look like, oh, like how to deal with it. Its summation is there, and then n is equals to 0 to infinity is there, but it's okay. Summation means we are just adding, we are going to add the terms. So if n value we will be putting 0, it will be a to the power 0, plus if n value we will be taking 1, it will be a to the power 1, plus if n value we will be taking 2, it will be a to the power 2, plus if n value we will be taking 3, it will be a to the power 3. Just like that it will keep on going, right Lena?
Yes,
Right.
ma'am.
Having 1 plus a plus getting multiplied with each and every term, and some of this type of infinite terms, some of the like a geometric series where we are having infinite number of terms is 1 by, what was the summation formula? 1 by Yeah, like it was not 1 by. What was the summation formula? You tell me. Have we discussed the summation formula of infinite series previous day? Yeah, what was the summation formula for infinite GP series? A by 1 minus R, right? Can you see? Sum of infinite terms is A by 1 minus R.
Yes, ma'am.
Okay. So this formula A by 1 minus R we are going to apply over here. Okay, let's do it. So that is A value. What is the A value? First term over here.
1.
What is the first 1, right? By 1 minus R. What is the common ratio? What is the common
Uh,
ratio, Lina? A. So
1 by
this is
n.
what is the summation of n is equal to 0 to infinity a to the power n. However, it was looking like so, like how we will be handling it, but we ended up getting x as a 1 by x as a 1 by 1 minus a. Okay. Similarly, y is also given and z is also given. So directly we are going to write. Okay. Directly we are going to write y will be 1 minus b and z will be 1 by 1 minus c. Is it okay?
Yes, ma'am.
Okay. Let's move ahead. Now, what exactly the question says? A, B, C are in AP. Okay. So, if A, B, C are in AP, then we have learned the properties of AP. That we can add something in every term with the same number and still it will be in AP, right? So we can say let's multiply each term with -1. Still it will be in AP, right, Lina?
Yes, ma'am.
Minus A, minus B, minus C are in AP. We can say we can add this in AP. Is it in AP? Tell me.
Yes, ma'am.
Not in AP, it's in HP. HP is the just the reciprocal of AP. If each term you will do reciprocal, then the resultant sequence will be in harmonic progression. Okay, Lina?
Yes, ma'am.
If you are saying 2, 4, 6, 8, this is a arithmetic sequence, then 1 by 2, 1 by 4, 1 by 6, 1 by 8, this will be harmonic sequence. Getting it?
Yes, ma'am.
So here we were having 1 minus A, 1 minus B, 1 minus C. It was in AP. Now we have taken the reciprocal of each and every one. Now it just got changed to H then X, Y, Z are in. So we can say X, Y, Z are in HP. Got it?
Yes, ma'am.
Let's move ahead. Similarly, if we are having a to the power x is equals to b to the power y is equals to c to the power z, and a, b, c are in GP, then x, y, z are in. Let's do this. So we can say, let's say a to the power x, b to the power y, and c to the power z is equals to k. Okay. So let's take logarithm with each and every term. So x log a. If we will be taking logarithm with a to the power x, log a to the power x, it will be x log a, right, Lina?
Yes, ma'am.
Is equals to y log b is equals to z log c is equals to log k. Now let's move ahead. So we can say x log a is equals to log k. So x is equals to log k by log a. Similarly, y is equals to log k. Each and every term we are comparing with the last term directly. This with this. Okay. Similarly, this with this. Similarly, z log c also we will be comparing with log k only. Okay. Let's do that. So y will be log k by log b, and z will be log k by log c. Is it clear so far? Tell me.
Yes, ma'am.
Okay. Now what exactly the question says? A, B, C are in GP. Now A, B, C are in GP. So previous day we were discussing one rule that when A, B, C are in GP, then log A, log B, log C will be in AP, right? How? Because when we started taking log A, log B, log C, the logarithm property we were applying, and then we realize, let me show you. Can you read? If A1, A2, A3 are in GP, then log A1, log A2, log A3 are in AP. Can you see?
Yes, ma'am.
Logarithm of each and every term will be in AP. Why? Because whenever we apply the property of logarithm, we start getting the multiplication become addition, division becomes subtraction. So that's why we end up getting an AP. Okay, so if A, B, C are in AP, can we say log A, log B, log C are in AP? Sorry, if A, B, C are in GP, then log A, log B, log C are in AP, right, Lita?
Yes, ma'am.
Right? Now we just have to make it like this. Okay. So we will be dividing each term by log k. Log a by log k, log b by log k. In AP, there is a property that add it, subtract it, multiply it, divide it. Still, it will be in AP. Only one thing you have to be careful, if you are taking the reciprocal, it will change to HP. Okay. Log C by log K. So each and every term we are just dividing by log K, and is still it will be in AP only. Now let's take the reciprocal of each and every one. So log K by log A, log K by log B. We just did the reciprocal, and now it will be in HP. Got it? Got it, Lina?
Yes, ma'am.
Let's see some properties of HP. Now let's see the property of HP. So the property of HP is A, B, C are in AP. Always we will be finding the property with the help of A, B, C are in HP with the help of arithmetic progression. As I said in the very beginning, no need to memorize the formula for harmonic progression. Always just try to relate it with arithmetic progression. So if A, B, C are in HP, can I say 1 by A, 1 by B, 1 by C will be in AP? Can I say, Lina?
Yes, ma'am.
And for AP, we know the property that common difference will be same. So the second term minus first term, this common difference must be equals to the third term minus second term. If we will just bring to one side, it will be 1 by A plus 1 by C, right? So we can say it will be, it still, if we wanna calculate it, here it will be AC, here it will be C plus A, and here it will be 2 by B. So if we want to, if we will do crisscross, you can say, so 2AC is equals to B times A plus C, and then B is equals to 2AC by A plus C. This is the formula for HP. How it came? It just came from AP. Can you see?
Yes, ma'am.
So HP formula, the way you are having for geometric progression, if A, B, C are in AP, then directly you go and write that 2B is equals to A plus C. That is for AP. When it is in GP, then directly you go and write B square is equals to AC. Now, from now, we will be writing when it is in HP, then 2AC by A plus C is equals to B, or B is equals to 2AC by A plus C. From where exactly it came? It came from the concept of arithmetic progression only. Got it?
Yes, ma'am.
Now, arithmetic, geometric progression. So, if we are having an arithmetic progression 1, 2, 3, 4, 5, this type of sequence we are having, let's say, and a geometric series we are having x square, x cube, x to the power 4, x to the power 5. This way we are having a geometric sequence. Then AGP we can create with this one, that is we can do the multiplication of both the this AP and GP. If we will multiply both of them, we will be having x, 2x square, 3x cube, 4x to the power 4, 5 create AGP. What is the meaning of AGP? AGP means arithmetic geometric progression. Here the arithmetic progression and the geometric progression both will be mixed up. How you will be identifying that? You need to check here the first term, here the first term, here the first term, here one of the term, here one of the term. Is it maintaining any sequence? Is it maintaining the pattern of GP or AP? Or in the first term, in the first in the first term, like this one, this second one, third one, fourth one, fifth one, there you will find a pattern that, like one of the term from each and every term, like the, like one number or some, like term only, you can say one term from here, one of the number 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 from the next one. It is maintaining a pattern. Either it will be maintaining a pattern of AP or GP, and the other one will be maintaining the pattern of other one. That's why the name is AGP. Okay. Okay, Lina, are you understand the meaning of AGP?
Yes, ma'am.
Now, how to find let's find the sum of AGP. So suppose our terms are x, 2x square, let's say the above one only, 3x cube, 4x to the power 4, 5x to the power 5, just like that till infinity. Okay. Now, while taking out the formula for geometric progression, what we have done, we have multiplied both side by r, right? Here, what is r?
Yes,
Can
ma'am.
you tell me? What is the common ratio? If you will focus on only geometric series over here, what is the common ratio? x, x square, x cube, x to the power 4, x to the power 5. What is the common ratio over here, Lina? Yeah, if we are having the geometric series as x square, x to the common ratio over here. Yeah,
X.
x only. So we will be multiplying x on both sides. So this first term became x square. I am writing it below this. The second term became 2x square, 2x cube. I am writing it below x cube. The third term became x to the power 4. I am writing it below it. The fourth term became 4x to the power 5. I am writing below it just like that infinity. Is it clear so far how we are doing the multiplication and writing it by shifting one place?
Yes,
Now
ma'am.
let's do the subtraction. Okay. Now let's do the subtraction. So here we will be having s minus x s, and here we will be having x. 2x square minus x square is x square. 3x cube minus 2x cube is x cube. 4x to the power minus 3x to the power 4 is plus x to the power 4 plus x to the power 5 plus like that infinity we will be having, right, Lena?
Yes, ma'am.
As common we can take 1 minus x, and the right hand side if you will focus x, x square, x cube, x to the power 4, x to the power 5, it's again a purely geometric series, right, Lena?
Yes, ma'am.
Purely a geometric series, infinite geometric series, where we have learned the formula as infinity formula was a by 1 minus r. Here a is, what is the value of a? The first term is, the first term is,
X.
r is 1 minus x, right?
Yes, ma'am.
So the sum formula is x by 1 minus x whole square. This is the formula we got for AGP, the sum of infinite terms. Okay. Okay, Lina. Let's see how to
Yes, ma'am.
apply this formula. You can note down this formula. Or you just understand this process. Okay. Rather than using the formula every time, if you will understand this process, that whatever is the common ratio, we are, whatever, if we are having s, if we are having s as 2 by 3, 6 by 3 square, 10 by 3 cube, 14 by 3 to the power 4 plus dot dot dot. This is AGP. Here 2, 6, 10, 14. This one is arithmetic series, and by 3 square by 3 to the power 3 by 3 to the power 4. This is in geometric sequence. Okay. So let's do it. What we do, whatever is the common ratio, we multiply with that. 1 by 3 into S. So what we do, we multiply with the common ratio both side, and directly applying the formula. If you will learn the process, it will help you. So 1 by 3 will be multiplied. Let me share. Can you see this? Please me know.
Yes, ma'am.
Hi, so this is what we will be getting over here, right? Now,
Yes,
can you
ma'am.
see this one is completely 4 by 3 square, 4 by 3 cube. It's following a pattern, but the first term it's not following a pattern, right? If we will take out 4 common from the rest of the term, it will completely be in GP, right? 1 by 3 square, 1 by 3 cube, 1 by 3 to the power 4, 1 by 3 to the power 5. But it starts from the second term. Okay, not the first term. So no worry, we will be copying down the first term. 4 we will be taking out common. It will just completely become the geometric series. Okay, where we know the sum of infinite terms formula is a by 1 minus r. Here a value is 1 by 3 square, that means 1 by 9, and r is 1 by 3 cube divided by 1 by 3 square. If you will do, you will be getting r as a 1 by 3. Okay, so let's apply the formula. 1 by 9 divided by 1 minus 1 by 3. This is what we are applying the formula over here. And the first part, 4 is common out. We will be copy pasting the 4 as it is, and the first number 2 by 3 we will be writing as it is, because that was not making the sequence. So no worry, one extra term is there. We will keep on writing that, and in the sum we will be saying one extra term came out. Okay. Now the left hand side, s minus 1 by 3s, that too we will be doing. That will give us 3s minus s, that means 2s by 3. We just have to find s over here. No, you don't have to get worried whether you are applying the formula completely, whether you are adding them manually or whatever. So we are getting 2s by minus will go up, this will come down. So we will be having 2 by 3 plus 4 and into 3 by 9 times 2, 3 times 9. So we got 4 will also get cancelled. So we will be getting 2 by 3 plus 2 by 3 is equals to 2s by 3 is still there, and we just want to find the value of s from there. Okay, so 4 by 3 is equals to 2s by 3, and s value we got as a 4 into 3 by 3 into 2, 3 gone. We got s as a 2. Is it clear?
Yes, ma'am.
Just see the process. The process. You don't have to memorize the formula. The previous step, please see the process rather than the formula. So the process says if s is equals to this is there, and if it is agp, then how we will find the sum? We will see what is the common ratio. We will be multiplying both side common ratio, and then we will shift one place. Once we will do that, and then we will do the subtraction of both the sequences, we will see a pattern is getting followed. So the possibility is totally the pattern is getting followed, or just like that you will be having one extra term or two extra term which is not coming in the pattern. So that's fine, just keep it aside and just keep on copy pasting it in each and every step, and just look at the pattern. If it is infinite geometric series, apply the formula of infinite geometric series and then do the calculation. You will get the value of s. Got it?
Yes, ma'am.
Okay, Lena. So yeah, today we have covered HP and AGP. I'm today keeping this much only. We will be continuing this topic. I'll be taking one more day to finish it. Still a lot of things are left. Like we have to cover the relation between AP, HP, GP, and we will be covering one more topic. So two more topics are left, which we will be covering in the next class. For today, I am keeping it this much. And yeah, if you want to ask anything from here, please do ask.
No, ma'am.
Then let's keep it this much. Let's continue the same in the next class. Okay.
Okay, ma'am.
And yeah, give the assessment